Okay, let's get going now. If f of x equal to 2 over x plus 1 and g of x equal to 3 over x, construct the composite function f circle g of x and specify its domain. Given f of x equal to 2 over x plus 1 and g of x equal to 3 over x, we can compose the function f, which will have its argument the function g of x. So f of g of x equal to f of 3 over x. F of 3 over x is nothing but, like, we replace x here and x here by 3 over x. If we do so, then f of 3 over x will be equal to 2 divided by 3 over x plus 1. If we multiply the denominator and numerator by x, we will get 2x over 3 plus x. This is the first part of the question, which is the construct. This is the construct for the composite function. Now let's get going with the other part, which is the domain. We want to find the domain. To find the domain, we're going to have a diagram over here. G of x receives as input x, and it produces as output 3 over x. So this is g of x. Its output is going to be 3 over x. Its output is going to be fed into the function f of x. So f of x will get 3 over x going in. Since 3 over x implies that the domain of g of x cannot have x equals 0, that means 0 is not included in the domain of g of x. So if 0 is not included in the domain of g of x will never produce 0. So that means what? 0 is not going to be in the domain of f of x also, because f of x receives its domain value from the range of g of x, and g of x will never produce 0. For that, 0 is not in the domain of the function f of x. Now, the function f of x should not have x equal to negative 1. X equal to negative 1, that means whatever we receive from g of x should not be equal to negative 1. And the only time we can get negative 1 is when x is equal to negative 3. So when x is equal to negative 3, g of x will produce negative 1 and send it over here. Negative 1 is not allowed here, and for that reason, negative 1 is not allowed. That means negative 3 is also not allowed. That means g of x, its domain, should not include 0, because that will give us infinity, and should not include negative 3, because negative 3 will impact over here on f of x. It will give infinity over here. So that means the domain of g of x should not include 0, should not include negative 3. And that means we can conclude that the domain is from negative infinity to 0, union 0 to negative 3, union negative 3 to infinity. That is the domain of g of x, which is also the domain of the composite function. This is the composite function, and this is the construct. So the domain of the composite function is the same as the domain of g of x. And here is the domain, and here is the construct. Now we have to match and see which answer is the correct answer. And the correct answer is therefore part C, because part C, it has 2x over x plus 3, and the domain is infinity, negative infinity to negative 3, union negative 3 to 0, union 0 to infinity. So the correct answer is C. Okay, evaluate the expression tan pi over 3 plus cosine 4 pi over 3 plus cosine 3 pi over 4. Pi over 3 is 60 degrees. 4 pi over 3 is 240 degrees. 3 pi over 4 is 135 degrees. So we can just rewrite, instead of tan pi over 3 will be tan 60, and similarly there will be cosine 240 and cosine 130. These we could put the representatives. This will remain the same, tan 60, but over here cosine 240 is equal to negative cosine 60, and cosine 135 equal to negative cosine 45. So let's figure out these values. So we have these two triangles will give us these values. So we'll just go ahead and go to the computation. Tan 60, we can get it from here. It is the opposite divided by the adjacent. So square root of 3 divided by 1 is square root of 3. Minus cosine 60. Cosine 60 is nothing but the adjacent divided by the hypo. So it's going to be 1 over 2. So negative of cosine 60 is negative 1 over 2. And then we have negative of cosine 45. Cosine 45 is adjacent divided by the hypo, which is 1 over square root of 2. But we want negative cosine 45, so that's negative 1 over square root of 2. Now we can collect all these together. We will get square root of 3 and then minus 1 plus square root of 2 divided by 2, which is the collection of these two. We take as a common factor 2. And when we divide 2 by 2, it's going to be equal to 1. So we'll have the 1 up there. But then 2 divided by square root of 2 will give us square root of 2. So we have to multiply this by square root of 2. And of course, we take the minus outside, so everything will be plus. And this will give us square root of 3 minus 1 plus square root of 2 divided by 2. And I think this will match, which one? It looks like it's going to match D. Yes, so it matches D, so D is a correct answer. Let f of x be defined by f of x equal to x squared minus 9 divided by x minus 3 when x is not equal to 3, and f of x equal to 6 if x equal to 3. Question: where, if any, is f discontinuous? Let's go ahead and consider f of x has two branches. F of x equals to x squared minus 9 over x minus 3 where x is not equal to 3. This is for the first branch. For the second branch, f of x equals to 6. Now we could just go ahead and manipulate this. So x squared minus 9, its factors are x minus 3 multiplied by x plus 3. And of course the denominator is x minus 3, so we can cancel x minus 3 with x minus 3. So f of x will be equal to x plus 3 based on the first branch. Thus the domain for this branch is from negative infinity to 3 union 3 to infinity, because x equals 3 is not included. So that's why we're excluding 3 over here. Now that is, the number 3 is not in the domain and the number 6 is not in the range. Why? Because if 3 is not in the domain, then f of 3 is equal to 3 plus 3, 6. So 6 is not in the range. Now, based on the second branch, f of 3 is equal to 6. Combining the two makes the domain from minus infinity to infinity and the range from negative infinity to infinity. So the domain and the range are all the same. Now if we look at the two branches, we can get the derivative of this quotient using the quotient rule. So the derivative of this quotient exists except for when x is equal to 3. But when x is equal to 3, the derivative will take the second branch. So derivative of f of x when x is equal to 3 is going to be equal to 0, because derivative of 6 is 0. So the derivative exists over here. That means the derivative exists everywhere, and that leads us to the conclusion that it follows that the function is differentiable everywhere, which implies the function is continuous everywhere. The answer is therefore option D, because option D says that the function is discontinuous nowhere. Evaluate limit as x approaches plus infinity of the square root of x squared plus x minus x. This type of function we have to use the conjugate, and if we do so, then we will have this bracket multiplied by the numerator, which is the conjugate. So these two will result in x squared plus x minus x squared. Denominator will remain the same, which is square root of x squared plus x. Now we can cancel x squared with negative x squared. We'll be left with x divided by denominator, but we want to take x squared from inside the square root. If we take x squared outside, then it will be coming outside as x, and then inside we will have 1 because we take x squared outside, and over here we don't have x squared, so we can consider x to be equal to x squared divided by x. When we take the x squared outside, we will have 1 over x. So 1 over x, and we are also taking this x outside these brackets. So the x is outside, so we have 1 over here. One more time. There are 3 terms here, 2 under the square root and 1 by itself. All have a factor, that is x. So to take x outside as a factor, this x will be going outside and it will have 1 over its place. But from the square root we have to take x squared. When we take x squared, of course this is x squared and this is x, so we can consider this as x squared plus x squared divided by x. And then we take x squared outside of the square root, we will get x. So in the end, if we do the math correctly, that's what we're going to have, 1 divided by square root of 1 plus 1 over x plus 1. Now we have to take the limit of this one to answer the question. Therefore, limit as x goes to infinity of 1 divided by square root of 1 plus 1 over x plus 1. Of course, when x approaches infinity, then this term will be equal to 0. So it's the square root of 1 plus 0 plus 1. So if we do the math correctly, that's going to give us 1 over 2. Therefore, the correct answer is B. True or false? If f and g are functions such that limit as x approaches c of f of x equal to negative infinity and limit as x approaches c of g of x equals to negative infinity, then limit as x goes to c of the difference between the two functions equals to 0. Now, let's take a look at the limit as x goes to c, approaches c, of f of x minus g of x. We can take the limit inside, it will be limit as x approaches c of f of x minus limit as x approaches c of g of x. But we're given limit as x approaches c of f of x is equal to infinity. So this limit is equal to infinity and this limit is equal to infinity also. This is negative infinity and this is negative infinity. So it will be negative infinity minus and then negative infinity. And that will give us negative infinity plus infinity. However, this is undefined. We cannot do subtraction at infinity. So thus the answer is false. That means it's not true. This statement is not true. We could also handle this in a different way. We can use proof by contradiction as follows. We will show the conclusion that the limit as x approaches f of the difference equal to 0 is false. How? If the conclusion is true, then we will take the limit inside. So limit of f of x as x goes to c equal to 0, and limit of g of x as x approaches c also equal to 0. But these contradict the statement, the hypothesis. The hypothesis says that this limit is equal to negative infinity, negative infinity. But if we use limit of the difference to be equal to 0, then we execute the limit inside. That will give us the limit of each function as x approaches c is equal to 0, which is contradiction. We could also do it in a third way. We can also state that f of x has vertical asymptote. Y approaches negative infinity as x approaches c. However, g of x does not have to be equal to f of x to have the same asymptote. That is, f of x minus g of x does not have to be equal to 0. And that shows that the statement is indeed false. An object moves along the x-axis so that its velocity at time t seconds is v of t equals to 2 divided by 3t meters per second. What is the average acceleration? That is, average rate of change of the velocity of the object over the time interval 2, 2 plus h. What is the acceleration of the object at time t equal to 2 seconds? V of t is equal to 2 divided by 3t. Therefore, v prime of t equal to limit as h goes to 0 of v of t plus h minus v of t divided by h. We can just go ahead and substitute. Instead of v of t plus h, we will get 2 divided by 3 multiplied by t plus h minus 2 divided by 3t. This is v of t and this is v of t plus h. And now we divide all by h. And this is equal to limit as h approaches 0. If we have a common denominator for these two, that will be 3t multiplied by t plus h, and then we will get 2t and then minus 2 multiplied by t plus h. And of course, this is divided by h all total. This could be equal to limit as h approaches 0 of 2t minus 2t minus 2h divided by the common denominator, which is h multiplied by 3t all multiplied by t plus h divided by 1. I just took the h up there and we have 1 over here. Now this could be rewritten as limit as h goes to 0. We will have to cross the 2t with the 2t. We will be left with negative 2h divided by h multiplied by 3t all multiplied by t plus h. We can also cross out the h with the h, and that will give us limit as h approaches 0 of negative 2 multiplied by 3t all multiplied by t plus h. And this is equals to negative 2. We can take the 3t inside. We'll get 3t squared plus 3th. Now, therefore, for time t equal to 2, which is the answer of the first part, this is going to give us negative 2 divided by 3t squared plus 3th we plug in instead of t2. So if we plug in 2 here, t square means 2 square, that means 4 multiplied by 3, that's going to give us 12. And then 3 times t is equal to 2, so it will be 3 times 2, which is equal to 6h. This is plus 6h. Now we could just go ahead and divide by 2 the numerator and the denominator, and that will give us negative 1 divided by 6 plus 3h. That is the first part. The second part is for which we have to take the limit as h approaches 0, and if we plug in 0 over here, we'll end up with the average velocity negative 1 over 6. So the two answers are negative 1 divided by 6 plus 3h and negative 1 over 6. And this matches the answer C. So the answer C is negative 1 over 6 plus 3h meters per second square, and negative 1 over 6 meters per second square. Evaluate the following limits. Limit as t approaches negative 3 of t plus 2 divided by t minus 7, and limit as x approaches negative 3 of x squared minus 9 divided by x plus 3. For the first, we're just going to go ahead and replace every occurrence of t by negative 3. So we'll have negative 3 plus 2 in the numerator, and denominator we're going to have negative 3 minus 7. And if we do the math, negative 3 plus 2 will give us negative 1. Negative 3 minus 7 will give us negative 10. And this will be equal to 1 over 10. As for the second one, first of all, we have to rewrite the numerator. And we can do it as follows. Limit as x approaches negative 3 of x minus 3 multiplied by x plus 3. But then this is divided by x plus 3, so x plus 3 cancels x plus 3, and the limit will be limit as x approaches negative 3 of x minus 3. So we will plug in, instead of x, we'll plug in negative 3 minus 3 will give us negative 6. And that means the correct answer is E, because E has 1 over 10 as the first, and the second negative 6, which is this. Find the limit of f of x as x approaches 2 if f is defined by f of x equals to 1 when x is not equal to 2, equal to 0 if x equal to 2. Limit as x approaches 2 from the left is equal to 1, and limit as x approaches 2 from the right also equal to 1. Therefore, limit as x approaches 2 equal to 1. And the correct answer is therefore A. Evaluate limit as x approaches negative 4 of x plus 4 divided by absolute value of x plus 4. Since the denominator cannot be equal to 0, this implies x cannot be equal to negative 4, because if x is equal to negative 4, we'll get an undefined function. That's not allowed. So x cannot be equal to negative 4. As such, either x greater than negative 4 or x less than negative 4. For x greater than negative 4, that implies x plus 4 is greater than 0. Hence, the limit as x approaches negative 4 of x plus 4, which is positive, divided by x plus 4, which is positive. So since both of them are positive, the limit will be equal to 1. One more time. As x approaches negative 4, x plus 4 will be positive. And x plus 4 in the denominator will also be positive, and that will give us the limit equal to 1. For x less than 4, this implies x plus 4 is less than 0. Hence, the limit as x approaches negative 4, in the numerator, it will be x plus 4, which is less than 0. The denominator, because this is the absolute value and we use the positive side, so this will be negative of x plus 4. Since x plus 4 is less than 0, negative x plus 4 will be greater than 0. Now, the numerator and denominator, they have different signs, so the answer is negative 1. The fact that we have the answer 1 and negative 1 implies that the limit does not exist, and the correct answer is E, does not exist. If limit as x approaches k of x to the power 4 minus k to the power 4 divided by x minus k is equal to negative 32. Find k. We're going to go ahead and rewrite the function. So limit as x goes to k of x to the power 4 minus k to the power 4 divided by x minus k equals to limit as x approaches k of x squared plus k squared multiplied by x squared minus k squared. We could go ahead and factor out also this one, and this will give us limit as x approaches k of x squared plus k multiplied by x plus k multiplied by x minus k. These are the two factors of the second. So we can see that x minus k cancel out the denominator. So x minus k in the numerator cancels x minus k in the denominator, and we're left with two parentheses multiplied, and that's going to give us limit as x approaches k of x squared plus k squared multiplied by x plus k. Now we replace each occurrence of x by k, so we will get for the left parentheses, instead of x squared plus k squared, we'll get 2k squared, and instead of x plus k, we'll get 2k. So 2k squared multiplied by 2k is 4k cubed, and we're given that this limit is equal to negative 32. So 4k cubed is equal to negative 32. We divide both sides by 4, we get k cubed equal to negative 8, and this gives us k equal to negative 2. So the answer is k equal to negative 2. Find the slope of the tangent line to the curve y equal to 4x minus x squared at the point negative 1, 0. So we will get the slope, and then we plug in the values of x and y. So to find the slope, we're going to go ahead and look at y equal to 4x minus x squared. So derivative of y represented by y prime equal to 4 minus 2x. But we know the value of x is negative 1, so we could just go ahead and evaluate y prime to be equal to 4 minus, instead of x, we will put negative 1. So 4 minus 2 times, instead of 2 times x, 2 times negative 1, and this can give us 4 minus 2 multiplied by minus 1, that is 4 plus 2, which is going to give us 6. So the correct answer is A. Find the equation of the tangent line to the curve y equal to 2x minus x squared at the point 2, 0. The slope for y is given by y prime equal to differentiate 2x to 2, differentiate x squared to 2x. So it will be 2 minus 2x. Now we have to use the point 2, 0. Then the slope will be given by 2 minus, and instead of 2x we'll put 2 times 2. So 2 minus 2 times 2 will give us 2 minus 4, which is equal to negative 2. The equation of the tangent will be given by y equal to the slope multiplied by x plus b. The slope is negative 2. So y equal to negative 2 multiplied by x plus b. Given that y equals to 0 and x equal to 2, we can rewrite this equation as 0 because y equal to 0. Okay, and x equal to 2, so we'll have negative 4 and then plus b. So 0 equal to negative 4 plus b. This will lead us to the fact that b will be equal to 4. So we can now write the equation of the tangent as y equal to negative 2x plus 4. This can be rewritten as y plus 2x minus 4 equal to 0, and this matches option number B. So the correct answer is B. Let f of x be a function such that limit as x approaches 0 of f of x minus f of x plus h divided by h equals to x to the power 3 minus 1. Find the slope of the line tangent to the graph of f at the point a, f of a. To do so, first of all, we write down the limit as h approaches 0 of f of x plus h minus f of x. This is reversed, so we reverse it. So it becomes f of x plus h minus f of x over h. And since we reverse this, we have to reverse also the right hand side, and that will be equal to 1 minus x to the power 3. So this is the reverse of the left hand side, and this is the reverse of the right hand side, and both of them equal to f prime of x. So if that is the case, then we can go ahead and look at the slope of the tangent at the point a, f of a, because f prime will give us the slope. So we're going to go ahead and replace, instead of x, we replace it by a. And if you do so, then f of a, f prime of a is equal to 1 minus a to the power 3, which is replacement. We just replace f prime of x by a and this x by a also, and that's what we're going to get. F prime of a is equal to 1 minus a to the power 3, which is the option number A. So the correct answer is A. Find the derivative f prime of x of the function f of x equal to 1 over square root of x. What we have is we have f of x equal to 1 over square root of x. This implies that f prime of x is equal to negative 1 over 2 x to the power negative 3 over 2. That could be written as negative 1 divided by 2 multiplied by the square root of x cubed. If we look into the possible answers, A is the choice. So the correct answer is indeed A. Find the slope of the line tangent to the curve x cubed y equal to 1 at the point 3, 1 over 27. To do so, first we have to use the implicit derivative of the given function, which is x cubed y equals to 1. So we will proceed with implicit differentiation as follows. First, this is a product rule, so we will differentiate with respect to x, and then we add that to differentiation with respect to y. So differentiation of x will be 3x squared multiplied by y, plus differentiation of y with respect to x will be x cubed multiplied by y prime equal to 0. Now we can move and solve for y prime. If we do so, y prime will be equal to negative 3x squared y divided by x to the power 3. And this is equal to 3 multiplied by y divided by x, because we cancel x squared from the numerator and x squared from the denominator. We will end up with negative 3y divided by x. If we replace x by 3, we get 3 on the numerator and 3 on the denominator, and that will cancel the 3, and the answer will be negative y, but negative y is equal to negative 1 over 27. So in this case, the correct answer is A. The correct answer is A. True or false? If limit as h approaches 0 of f of a plus h minus f of a divided by h equals to infinity, then the graph of f has a tangent line at x equals to a. The derivative of f of x is given by limit as x approaches h, f of x plus h minus f of x divided by h, which symbolically is equal to f prime of x. Now when x equal to a, then f prime of a will be equal to infinity, and the tangent line exists, and it is a vertical tangent line. The correct answer is therefore true. Assuming all the indicated derivatives exist, f circle g all prime of c is equal to one of these options. Let's proceed with the solution. Let f circle g of x, which is a composite function, be written as f of g of x, a function of a function. Therefore, the chain rule for this function is as follows: d by dx of f of g of x equals to derivative of the outside, which is f prime of g of x, multiplied by derivative of the inside, which is g prime of x. Replacing x by c, we get f circle g prime of c equal to f prime of g of c multiplied by g prime of c. The correct answer is therefore A. Find the derivative of y equal to tan of cosine x squared. We're going to go from inside out, so we start with x squared. Let u be equal to x squared. Therefore, derivative of u with respect to x is 2x. Let v equal to cosine x squared. So the argument of tan, which is cosine x squared, we're equating it with v. So let v equal to cosine x square. Therefore, v is equal to cosine, instead of x square, we use u. So v equal to cosine u. It then follows that dv by du is equal to negative sine u. Since y is equal to tan of cosine x square, and we know cosine x square is equal to v, so we can write y equal to tan, but instead of cosine x square, we put v. So y equals to tan v. Now we can get dy by dv. So dy by dv will be equal to sec square v. Now that we have all these derivatives, we can just use the chain rule. And for the chain rule, we say dy by dx equal to dy by dv multiplied by dv by du multiplied by du by dx. And we have the values for each, and they are color coded. So dy by dv is right here, dv by du is right there, and du by dv is all the way there. All we have to do is we have to replace each one of these by its value on the right hand side. If we do so, we're going to get, to start with, first of all, we have dy by dv is equal to sec square v, which is right here. dv by du is equal to negative sine u, which is right there, and du by dx is equal to 2x, which is right there. Now we will go ahead and gradually do the substitution. We know that v is equal to cosine u, so sec square v will be equal to sec square of cosine u, and we have sine u, and we know that u is equal to x square, so we'll have here sine x square. We replaced u by x square, and then we have 2x where it should be. Now we still have to do substitutions. The next substitution is we can just go ahead and do rearrangement. We'll take 2x all the way to the left, and we take the negative sign all the way to the left, so this is negative 2x, and then we have sec square of cosine u. We replace u by its value, so sec square cosine x square, and then that's multiplied by sine x square. And this is pretty much is the correct answer. So the correct answer matches B. So B will be the correct answer. Find f triple prime of 2 given that limit as h approaches 0 of f of x plus h minus f of x divided by h equals to x cubed minus 7. To start with, f prime of x, which is a derivative of y with respect to x, equals to limit as h approaches 0 of f of x plus h minus f of x divided by h, and this is given to be equal to x cubed minus 7. So since we're looking for f triple prime, let's find the second step, which is f double prime of x. So f double prime of x is going to be equal to derivative of this part with respect to x, which will be equal to 3x squared. We have to go one more step by doing the derivative of f double prime to get f triple prime. So f triple prime of x is equal to 6x. That's just the derivative of the right hand side. Now all we have to do is we want to substitute instead of x 2. So if we put 2 on the parameter of f triple prime, then it will be 2 multiplied by 6 here. So the result will be f triple prime of 2 equal to 12. If that is the case, then the correct answer is C. For the next three problems, use the equation L of x equal to f of a plus f prime of a multiplied by x minus a for approximating the cubic roots of numbers between 1 and 130 that are not cube numbers. Question number 1. How many possible values the variable a takes, which is this variable which is involved in the calculation of L of x. So how many possible values the variable a takes? That's the first part. And which of these values is the best for approximating the cubic roots of the numbers from 1 to 130 that do not have perfect cubic roots? To start with, the perfect cube numbers for the range from 1 to 130 are as follows: 1, 8, 27, 64, 125, and 216. The variable a can take any of these 6 values. The best value of a for approximating all the non-perfect cube numbers is 64. The correct answer are therefore 6 for how many perfect cube numbers between 1 and 130, and 64 for the number that could be used to approximate the cubic roots of numbers that are not cube numbers between 1 and 130. Using linearization, the cubic root of 99 approximately equals the number 99 falls between 64 and 125. Since it is closer to 125, then we will use 125 for approximating the cubic root of 99. It follows then that L of x, or x, is 99. L of 99 equal to f of a, or a is 125. So f of 125 plus f prime of 125 multiplied by x, which is 99, minus a, which is 125. Now f is the cubic root, so we're going to go ahead and say equals to f of 125 is the cubic root of 125 plus f prime of 125 is the derivative of the cubic root, and that's going to give us 1 over 3 the cubic root of 125 square, and this is multiplied by x minus a, which is 99, minus 125. We do the math correctly. Cubic root of 125 is 5, and then this, the f prime of 125, will evaluate to 1 over 75. But then we have 99 minus 125. So this is going to give us a negative value. The difference is 26, so it's negative 26. So we take the negative sign outside, it will change the plus into minus. And then the ratio will be 1 over 75 multiplied by 26, which is approximately equal to 4 and 2/3. The answer is therefore 4.6667. The best value of a for approximating the cubic root of 15 is, the possible values a can take are 1, 8, 27, 64, 125, and 216. As such, the number 15 falls between 8 and 27. Since 15 is closer to 8, the best value of a for approximating its cubic root is 8. So the answer is therefore 8. The derivative dy by dx of y squared equal to sine x squared equals to, let u equal to x squared. It then follows that u prime equal to 2x. Replacing x squared by u, we get y squared equal to sine u. So we replace x squared by u. So replacing x squared by u, we get y squared equal to sine u. Using implicit differentiation, we get 2y prime, which is derivative of the left hand side, equal to cosine u prime, which is derivative of the right hand side. Therefore, if we solve for y prime, we get y prime is equal to cosine u prime divided by 2y. And this is equal to, instead of u, we will put x squared. So it's equal to cosine x squared, and instead of u prime, we put 2x, because u prime is equal to 2x. So cosine x squared 2x divided by 2y. And this is equal to, we have the 2 goes with the 2, and we take the x to the left hand side, so it will be x cosine of x squared divided by y. But y is nothing but the square root of sine x squared. Therefore, the answer is x cosine x to the power 2 divided by the square root of sine x to the power 2. The derivative of the function y equal to x to the power x equals, anytime we have the independent variable, which is x, the exponent, we must use the natural logarithm for finding the derivative. To do so, we'll take ln of both sides. Ln of y will be equal to ln of x to the power x. So ln of y is equal to ln x to the power x, but this could be written as x ln x. Now we have to take the derivative of both sides. So derivative of ln y is 1 over y dy by dx equals to derivative of x ln x. We use the product rule. So it will be x derivative of ln x, that will give us x derivative of ln x will be 1 over x. So x multiplied by 1 over x, plus we have ln x, the derivative of x. Derivative of x is equal to 1, so ln x will stay the same. And now we can cancel x with x. We have 1 plus ln x, which is equal right here, 1 plus ln x. Now what we can do to solve for dy by dx, all we have to do is multiply both sides, this side and this side, we multiply them by y. If we multiply by y, we get what? Since 1 over y dy by dx is equal to 1 plus ln x, then multiplying both sides by y, we get dy by dx equal to y multiplied by 1 plus ln x. But then we have to replace y by its value. The value of y is x to the power x. Replacing the value of y by x to the power x, we get dy by dx equal to x to the power x multiplied by 1 plus ln x. The answer is therefore dy by dx is equal to x to the power x multiplied by 1 plus ln x. The derivative of the function y equal to arc sine x equals, y equal to arc sine x implies y is equal to sine inverse of x. Pretty much the same. Arc sine x is like sine inverse of x. To find the derivative of y, first of all we have to apply sine x to both sides. If we do so, taking sine of both sides, we get sine y equal to x. Because we take sine here to the left, it will be sine y. And then we take sine of sine inverse of x will give us x. So sine y is equal to x. Now we can take the derivative of both sides. Taking the derivative of both sides, since y is a function of x, then derivative of sine y will give us cosine y dy by dx. Derivative of the right hand side is going to give us 1 because it's with respect to x. Now we have to solve for dy by dx. If we do so, then it will follow that dy by dx is equal to 1 over cosine y. We don't have any way of finding cosine y, so we have to get back to where we started, which is sine y equal to x, and we have to represent this one using a triangle. So here is a triangle, this is the angle y. We can see that the sine of this angle is equal to the opposite divided by the hypo, but the opposite divided by the hypo will give us x. So sine y is equal to x divided by 1, which is equal to x. Sine y equal to x, so this triangle represents this one, so we could also extract cosine y from it. Since this is 1 and this is x, so the adjacent to y is the square root of 1 minus x squared, which is the square root of 1 minus x squared. All we gotta do now is just compute cosine y from this particular triangle, and cosine y is just nothing but the square root of 1 minus x squared. So we replace cosine y here by the square root of 1 minus x squared. So this is the replacement of cosine y by square root of 1 minus x squared. Therefore the answer is 1 over the square root of 1 minus x squared. That's it for this question, and that ends the solution to all the midterm questions. Good luck and study hard and have a nice day.